if we have a load, or a signal source, something like this, where we have a strong voltage, 1 volt, but it's not this power supply. This, for instance, some kind of sensor or something, can't really output any current. So it has a high output resistance of 1 mega ohm. This would be a common situation, and if we hooked it up to a smaller load, for instance, 1K, we lose all of our signal strength. So if V out, we can find that by a divider. What is the value of V out in this case right here? What is that value? So it's a divider. V out is 1K over 1K plus 1 mega ohm times 1 volt. And that will equal, if you put the numbers in, well, we've got 1,000 over 1, 1e to the 3 plus 1e to the 6 times 1. What we end up with is 1 millivolt, approximately. So that means we now have just 1 millivolt here, even though we had 1 volt on the input. We had this nice large 1 volt, but now we only have 1 millivolt, just because we hooked up this 1K load to this sensor. So one way to solve that situation, we could solve it with some kind of amplifier, but in fact, we could just use a simple op-amp circuit to solve that. If we add a voltage buffer, so if we've got this signal source, this high resistance, and we add that to the non-inverting pin, so we have a non-inverting configuration here. And we just, for a buffer, we just connect a wire for 100% negative feedback to the input. So we've still got 1 volt here, V out, 1K, 1 mega ohm. So the question is, what is V out now? Well, we've got this op-amp that ideally it has infinite output resistance. So, and we can write V minus and V plus up here if we'd like. Because there's no current flowing in to the op-amp, there's no current flowing in here and no current flowing in here, the virtual short is active. And that means that the value of V plus is forced to be on V minus. So V minus will be equal to V plus. And because there's no current into the op-amp itself, at least ideally, because this current here is 0, then the voltage, 1 volt, needs to be right here. So we've got 1 volt right there, which means we have 1 volt right here. It's perfectly equal to Vn. And the 100% negative feedback means that V out will be 1 volt. And the load current would now be 1 volt over 1,000 ohms, which is 1 milliamp. If we figured out what we would have for load current without the buffer, let's change color. We would have 1 millivolt on the output. and we still have 1,000 ohms, and that would give us a load current of 1 microamp. So we've got a much stronger result here, 1 milliamp output current, 1 volt, a much, much stronger result than the result with the buffer where we only had 1 millivolt here and 1 microamp. So a buffer is a really, really simple circuit, and it can really make your circuit work better. There's issues you have to worry about, the total load current available or output current from the op amp and things like that. But fundamentally, it's a really simple circuit to implement and a very useful circuit to use.